All right, guys. Welcome to our lesson on primary storage devices. Right. Of course, we are still talking about computer hardware, and my goal has been to actually start from input devices, we go to output devices, then we come to storage devices. But of course, I found this chance to actually record a lecture on storage devices. Of course, I will still have to come back to output devices because I remember my last lesson was on input devices. So the objectives of the lesson are as follows, right? By the end of this lesson, you must be able to define primary memory and give at least 3 examples of computer primary memory devices. Then secondly, you must be able to explain common features of primary memory. And then lastly, you must be able to explain at least how 3 primary memory devices work. Right? So let me define a primary memory. A primary memory is that memory of a computer which is directly linked to the processor. It actually means the processor can actually access the primary memory directly. So the primary memory is a section of a computer that the CPU can access directly. It has a faster access time than secondary memory, and it is slower than cache memory. Of course, we shall talk about cache memory in time. So primary memory, on average, has storage capacity that is lower than secondary memory, but it is bigger than cache memory. In other words, we are saying cache memory is smaller than primary memory. Primary memory is smaller than secondary memory. And then in terms of speed, cache memory is faster than primary memory. And then primary memory is faster than secondary memory. So primary storage devices are generally volatile, especially the RAM part. So the part of primary memory that is not volatile is called ROM, meaning read-only memory, as being opposed to RAM, which is random access memory. So look here, I've tried to differentiate the types of memory. The random access memory, which is divided into static RAM and dynamic RAM, and then you go to the ROM, which is divided into PROM and EEPROM and EEPROM. Of course, here we are not going to discuss about EEPROM, but we are going on the ROM part. We are going to discuss about PROM and EEPROM. So we are saying a primary memory is divided into 2: the volatile component, which is referred to as RAM, and the non-volatile component, which is referred to as ROM. To say RAM is to simply say random access memory. And to say ROM means read-only memory. So when we start a computer, all applications and data that are used by a computer are loaded by the operating system into the primary memory, which is mostly the RAM. Right? While those programs that help the computer start itself or do bootstrapping, they are loaded in the ROM, which is read-only memory. So the CPU then, when data and applications have been loaded into the primary memory, the CPU can now operate on the data and the instructions, accessing all the instructions and data directly from the primary memory. So primary memory is the directory repository, right, from which the processor can read in from and write into. So it is usually faster than the secondary memory, because we shall see that the technologies that make primary memory make it faster to access That is the concept of saying random access memory. You can access any part of the memory without some kind of sequential order in terms of which part of the memory you can access. This is the concept of saying random access memory. Each part of the whole memory of a computer is equally accessible without following a certain sequential order. And you will see that this is what makes it faster when compared to backing storage or secondary memory, where we are saying we will be using disk where the head needs to move from one point to another following some certain order so that it can access the data at a given point, which makes it slower. So random access memory is accessible. All parts of the computer memory, no matter how big the memory can be, they are equally accessible. We don't need to actually follow a certain order for us to reach a certain part of the memory. So random access means you can access any part of the memory at any moment. Right. So the volatile component of the primary memory, like we said, is called RAM. So as soon as the computer starts, the primary memory loads all running applications, including the operating system, the user interface, the user installed softwares and utility software and all those things. So you find all the working applications and all the data that are found in a computer during the time it is working, all is found in the primary memory. Of course, as we go on, you shall see us talking about the cache memory, right? Which is an extension of the primary memory to make the computer even faster, because the cache memory is almost inseparable to the CPU because it resides almost close to the CPU. So, but most of the programs, they are housed in the primary memory, which is called random access memory. And all working data and applications are organized in the random access memory by the operating system. So a program or application that is opened in the primary memory interacts with the system processor to perform application-specific tasks. What are we saying? We are simply saying all the applications that you click and use, during the time you are using them, they are residing in the random access memory, the volatile part of the primary memory, right? So that RAM itself can be divided into two, which are one, a dynamic random access memory and static random access memory. So when we say dynamic random access memory, we are talking about that part of the computer memory which is made up of transistors and capacitors. So it is the total memory will be a computer chip that contains millions of capacitors and transistors that would hold information in zeros and ones. The bit 0 referring to off, 1 being referring to on. So you find this is just emphasizing the fact that a computer is a digitized machine. It can only store data that is in base 2, right? So this is the function of transistors. They act like switches. They allow the chip to control circuit. They allow the chip control circuitry to read the capacitor or change the capacitor's value from 0 to 1 or 1 to 0. So to keep data in the dynamic RAM or in the DRAM, power must be on, and it must regularly refresh the memory within milliseconds. So it actually within a second, the dynamic RAM would have been charged with power.